All right, you should have gotten all the way through your simulation now. It should only take a few minutes because we're not going too far into what we're working with in our simulation, but I wanted you to get used to what's actually going to happen. So we're going to look at what actually happened when we clicked some of these buttons so that we know how to use our simulation a little bit better. If we click on the surface button, what you see is the land underneath the ice, the water, and other pieces of land, so like islands. So basically clicking on the surface button gets rid of all of the ice and water on Earth, so we just see that hard, rocky outer layer. When we clicked on the select button with the pencil and the blue outline, what that would do is add continents so that we can kind of mess around with what the Earth looks like. And when we do our plate motion later on, we can make our plate motion exactly how we want by adding continents if we want to study something that has a continent. By taking the upside down pencil, looks like it has the eraser there, that's going to remove continents. So if we have land that we want to get rid of and see how these plates interact underneath the ocean, then we can just remove the continents. Either way, though, you have a bottom layer of hard rock. And then finally, if you go back to your globe view, it will just show you the entire globe. So you should have gone back from like the region back into the entire Earth when you click on globe view, and we can see another area or see maybe how we actually changed our globe. So once we make changes in our plate motion simulation, we can go back to our globe view and see what happens on a zoomed out level, like to the entire Earth. So we're going to be using that a lot more. And when we use this, we are going to be seeing pages that look kind of like this. And what we're looking at here are plates. So plates and plate boundaries. Oops, didn't mean to click on that. So what we're looking at here are plates and plate boundaries. I'm going to go back one. Our top view here is the ocean, like looking down at the ocean. So this would be like how you would look at a regular map. If you've ever used Google Maps, it's usually looking down. That's this view right here. And we're just looking at the ocean. This is our cross-section view. So as you can see, we have the ocean is that dark blue, and then you have a hard rocky outer layer, and then underneath that, the mantle, which we'll talk about more later on. So our entire Earth is made of these plates, and these plates are these large pieces of rock. It's over. Large sections of hard solid rock that make up Earth's outer layer. And you can see in that map where we can actually map out all of our different plates. Now, continents are part of a plate. Remember that continents are not the plate themselves. That's going to be a really key point that we're going to make sure we can get across, that continents are not the actual plate. So when continents are moving around on Earth, which they are, and we'll talk about that, they're not just moving themselves, the entire plate is moving. As you can see down here in our cross section, this continent, which looks like an island up here, is actually part of the plate. It's connected to the hard solid rock down here as well. It just gets thicker where there's a continent and thinner where there's not a continent. What we're looking at in this map here is two different plates. Plate 1 on this side, plate 2 on this side. And you can see down here too where that green line is on our cross section going up and down, that you have plate 1 over here and plate 2 over there. Now, in that cross section, you can see hard solid rock, you can see the separation of land, and you can see the mantle. And that top hard solid rock is the actual plate. One thing we want to observe is patterns that we see in our plates, and that's going to help us study how these plates are moving and possibly where they actually are. So we're going to be looking at plate boundaries. Plate boundaries are the place where two plates actually meet. So if I have one plate here and one plate here, wherever they are touching, that touching point is what we call the boundary. And on our map, we're using a green line to represent the boundary. Obviously, in real life, we don't see a green line, but we will see physical land features there that will let us know that there is probably a plate boundary. And in our cross section, our green line goes vertical because we're looking at it sideways, and you can even see that little like crack in the earth right there where our plate boundary is. So right here, you have plate 1 on this side, plate 2 on this side, and then this green line represents where they actually meet. So we're going to look at a map next, and there are 4 different areas that I have highlighted. Today, we're going to be focusing mostly on area C, and this map shows the actual plate boundaries. All of these red lines are plate boundaries. what we're going to be doing a lot is studying earthquakes over the next couple of days. Now, I don't think I have to define an earthquake for you, but it is a sudden shaking of Earth's surface. Maybe you've actually experienced an earthquake. I have, but a very, very tiny one. Maybe you haven't, and you've just seen movies like San Andreas, and hopefully we get a chance to talk about like how realistic that is. But you know what an earthquake is, and you've probably seen like movies or something that represents an earthquake. Well, we're going to look at our earthquake maps. So our earthquake map here, this map dot, each little black dot represents a major earthquake from, I believe this is from 1990 to 1996, or maybe 2000. But we'll look at more recent ones as well. But, I'm sorry, it says it right down here, 1960 to 1990. So these are all major earthquakes that happened during that time. We're going to look at more recent ones as well, and you might be shocked as to how often they actually happen. And this is where you're going to come in next, because you are going to be actually doing some mapping of your own. So we know that these boundaries are where plates meet. Right now, we can see on our actual maps that we have earthquakes typically where these boundaries are. If you look at your earthquake map and your boundary map, they look very similar. A lot of the same lines, like this one going down the Atlantic Ocean and this one going down the Atlantic Ocean, tend to match up. So what I want you guys to do is try and figure out if you can actually fill in the rest of this plate boundary. If you double click on this area, your Google Draw will come up. And what I want you to do is, first off, color in your map so it looks like our key by clicking on each earthquake. And you can probably get to do this pretty fast. Click on each one and then fill them in so that they are filled in like our key. And you can actually see where earthquakes are. And then you're going to try and predict where your plate boundary is. If you click on this one that says line, you can actually change it to a scribble, and you can make it red to match the rest of them. And then what you can do is start to draw in where you think that plate boundary is and use your earthquakes as a guide. Once you have your line drawn, you can change the color. You can also change the thickness if you'd like, so that it's easier to see. But I want you to use your earthquakes to see if you can draw where that line actually is. Once you're done, make sure you click save and close so that when you go back to your classwork, you have your line drawn and everything is done for you like you did. And you can move on to our next section. Try not to scroll down because I want you to actually try and do this on your own, and then you will see what our boundaries actually look like.